Hi, my name is Chetan Anand, and this is my major project for the cybersecurity course. I built an intrusion detection system using a tool called Snort on Kali Linux. An intrusion detection system is a security tool that watches network traffic and tells you when something suspicious is happening. It does not block anything by itself, it just watches and raises an alert. Think of it like a security camera for your network rather than a locked door. In this project, I made Snort watch for three things: ping requests, file transfer protocol connections, and Telnet connections. Since these are common ways an attacker might first explore or access a system. For this, I have used two virtual machines. One is Kali Linux, where Snort runs and watches the traffic, and the other is Metasploitable 2, which is the target machine I am testing against. Metasploitable 2 is a machine that is built on purpose to have weak security, so it is commonly used by students and security professionals to practice testing safely without touching any real system. Both machines were connected using a bridge network, meaning they behave like two separate computers on the same Wi-Fi, which is closer to how things work in the real world compared to the other network setups. Before starting any test, I simply pinged the target machine to make sure both machines could talk to each other, and the ping was successful. So for this, first I updated the system using the apt update command so that the Kali Linux has the latest version of all the available software. Then I installed Snort using the command sudo apt install snort -y. Snort itself is a well-known open source tool that has been used in the cybersecurity field for many years to detect network-based attacks. Once the installation finished, I checked the version using a simple command snort -v, and it shows the version 3.12.2.0, confirming the install works correctly and was ready to be configured. Next, I opened Snort's main configuration file called snort.lua. This file controls how Snort behaves. It has several sections. For example, settings for which network to protect, settings for how to detect threat, and settings for how alerts should be displayed. In the network setting, I left the values open to any, so Snort would watch all traffic on the interface rather than limiting it to one specific address range. Then in the configuration detection section, I added a single line that tells Snort to also load my own custom rule from a separate file called local.rule. This is important because without this line, Snort would only use its built-in rules and would have no idea what I personally wanted it to detect. Then I wrote three simple rules inside the local.rule file. Every Snort rule generally follows the same basic pattern: an action, a protocol, the source and destination, and then a message describing what it found. My first rule watches for any ping, which is technically called Internet Control Message Protocol traffic. The second rule watches port 21, which is the port commonly used for the file transfer protocol. And the third rule watches port 23, which is the port used for Telnet. Each of these rules also has its own identification number so that later, when I look at the alerts, I can immediately tell which rule triggered which alert instead of just seeing generic warning. Before turning Snort on for real, I tested the entire configuration using the test flag. This step is something professionals always do before deploying any security tool live, because it checks whether everything is written correctly without actually turning on live monitoring. In my case, it loaded 222 rules in total, 219 that come built in with Snort, plus the three I wrote myself, and the test came back with zero errors. This gave me confidence that Snort was ready to be switched on safely. Once the test passed, I started Snort in live mode on the network interface, which means actively started watching the real-time network traffic going in and out of the Linux Kali machine. For the first test, I sent a ping from the Kali machine to the target machine. A ping is normally just used to check if a machine is online, but it can also be one of the first things an attacker tries while scanning a network. Snob picked it up right away and fired 10 alerts because it caught both detection of the traffic, the ping going out from Kali, and the reply coming back from the target. This showed that the rule was working correctly in both directions, not just one. Next, I scanned for the port 21 and it gave the result. Then I connected to the target using the file transfer protocol and tried logging in anonymously, meaning without any real username or password. It actually worked, which revealed the file transfer protocol service on the target was running, a very old and unsafe version. With a publicly known security hole, the attacker could exploit to gain unauthorized access. I also ran a separate network mapping scan to double check that the port was genuinely open, which it was. Snort caught this entire connection as well and logged it correctly, showing that it can detect not just basic things but also real protocol level activity. Now, after that, I scanned for the port 23 and it gave the result. I connected to the target using Telnet, which is much older way of remotely logging in into a machine, unlike modern alternatives. Telnet does not encrypt anything, meaning if a real attacker captures this traffic, they could potentially read username and password in plain text. The connection worked and it even showed me the system's login screen. Once again, the connection worked and the network mapping scan confirmed the port was open and the Snot successfully logged the alert for the Telnet connection as well, completing all three planned attacks simulation. At the end, I looked at the full alert log together, combining all three tests. It showed over 20 alerts for the ping test alone. Since that one generates traffic going both ways, it showed 4 alerts for file transfer protocol connection and 2 alerts for the telnet connection. Every single alert had a correct timestamp, the correct source and destination address, and the correct rule identification number, which confirmed that Snort was tracking everything accurately and consistently throughout the entire test. The Telnet port sends everything unencrypted, and even other services like the file sharing port and the chat server port on this machine had their own publicly documented vulnerabilities. This really showed me how, in real production environment, and even a single overlooked service could become an entry point for an attacker. So overall, this project really helped me to understand how an intrusion detection system works in practice, not just in theories. Snort continuously watches the traffic, compares it against a set of rules, and the moment something matches, it raises an alert with relevant details. All three of my test attacks were detected successfully with zero missed alert, which means the system worked exactly as planned. If I were to take this further, the next step would be adding more rules to cover additional services and possibly connecting these alerts to centralized monitoring system, which is closer to how this would actually be deployed in a real organization.